After watching the manufacturing process of the wind turbine main shaft, I finally understand why a seemingly simple wind power generation device can cost tens of millions. Just the engine main shaft alone requires ultra-high specification metal and takes 3 days to produce. The craftsmanship details are comparable to those of military enterprises. Here is the first step in the local wind power manufacturing plant's production of turbine main shafts. Workers first move this metal piece, weighing tens of tons, into the workshop. Then divide the alloy steel in front of them both horizontally and vertically, and calculate the specific dimensions needed for this process. Once the preparations are complete, we now officially move to the cutting stage. Due to the exceptionally large size of the metal, an automatic cutting machine is used in this stage. Workers only need to set the movement track, and the machine can automatically split the metal into two, with the edges being exceptionally neat without any flaws or gaps. It is then transported to the furnace, where the raw material is prepared for high temperature heating at 1200 degrees, lasting for more than 2 hours. The moment the furnace door opens signifies that this heat treatment can come to a close, but there is no time to rest. The mechanical vehicle needs to quickly lift the workpiece and transport it forward. The massive metal seems insignificant in front of the mechanical vehicle, but judging by the fully protected staff nearby, the next stage does not seem easy, especially at the moment when the 2,000-ton press comes into contact with the bow and arrow. The surface oxide layer crackles and falls off instantly. If adequate protection is not in place and the iron sheet comes into contact with the skin, the terrifying screams would surely echo throughout the area. Then the pressure disc is laid flat on top of the bow and arrow, and under the effect of hydraulic pressure, the metal gradually becomes smoother. Its shape resembles a large white rabbit candy, except this thing is likely to be quite hot to the touch. Then it is transported forward again. Now we enter the forging process. Forging is not just to simply obtain the shape of a bow and arrow. By applying pressure to the material, it can also, to some extent, eliminate the porosity and instability that occur during the metal smelting process. Additionally, it can improve the internal structure and enhance mechanical properties. After several rounds of forging, this block of square iron turns into a solid cylindrical iron piece. Then, the surface is repeatedly forged at high frequency until it becomes a completely cylindrical steel, marking the end of the second forging process. Next, a robotic arm places it into a mold, aligns it precisely, and prepares it for the final round of forging. Under the pressure of thousands of tons, the metal quickly adheres to the inner wall of the mold. With each round of pressing, the surface becomes more refined. Once the surface reaches the desired horizontal dimensions, it is slowly moved out of the forging position. Next, preparations are made to dismantle the mold. As for removing this thing, it involves repeatedly applying force downward. After 5 rounds of processing, this large pin was finally extracted. This is the initial shape of the wind turbine main shaft, which is then placed in an open area outside the factory to cool naturally. After several hours of cooling, the electric furnace is reopened, and a cart full of workpieces is pushed into the furnace. This process is known as tempering. Compared to ordinary bows and arrows, the tempering process for this big guy is particularly lengthy. It was heated in the furnace for a full 24 hours before completion. What you see now is the iron lump after tempering and cooling, ready to be machined into a bow and arrow. First, it is adjusted onto the lathe operation table, and then the triangular chuck is firmly secured using external tools. At the same time, the lathe switch is activated, allowing the machine to drive this piece of metal, achieving semi-automatic turning. In no time, the original color of the metal surface appears. Although this only takes a few seconds, in a real factory, it took more than 3 hours to complete the machining. The image shows the main shaft of a wind turbine. Do you know how heavy this solid iron lump is?